Hi everyone, welcome back to our channel. We are from Sri Vishnu Engineering College and today we'll be explaining about local and global variable, pass by objects, recursive functions in Python. This video is presented by CH Hasini, CH Manognya, K Madhavi under the guidance of Dr. M. Prasad, PhD, Associate Professor of Department CSE, SWEC Bhimavaram. Now let's get into the video. The first topic is local and global variables. What are local variables? Local variables are the variables which are declared inside the function blocks. In Python, local variables can be declared at any location in the code block. Only statements that are written inside a function can access local variables. They are secure in a way that no other function or variable of that program can access them. Local variables are created during the execution of the function and are destroyed once the block has finished. As soon as the execution leaves the block in which a local variable is declared, it loses all its content. It happens because local variables are always stored on the stack. Now let's take a look at one example. In this example, we have considered a greet function. In that function, we have declared a local variable named message. Once we tried to print the message inside the function block, we could see that it printed without any errors. But once we tried to print the same message outside the function block, we could observe a name error. This is because here the function variable is local to that greet function, so it can only be accessed within the function. That's why we get an error when we try to access it outside the greet function. To fix this issue, we can make the variable named message global. Global variables. Global variables are the type of variables that are declared outside of every functions of the program. The global variable is contrast to local variables. It is accessible by all the functions in the program. They continue to exist until the entire program has been ended. Global variable hold on to their values throughout the program execution. A global variable is useful when many functions are using the same set of data. Utilizing a lot of global variables could be challenging. They could undergo changes in values. Let us look at this example. This time we have declared the message variable outside the function block, which is a global variable. Once we declare a global variable, it can be accessed inside the function as well as the outside the function. We can see when we print the message inside the function, it prints without any error. As well as when we try to print the same message outside the function, it prints without any errors. This time we can access the message variable from outside the greet function. This is because we have created the message variable as global variable. Now message will be accessed from any scope of the program. Now the second topic is pass by objects. In Python, when we pass an object as an argument to a function, it is important to understand the concept of pass by object. Python follows a pass by object reference mechanism, which means when we try to pass an object to a function, a reference to that object is passed rather than the copy of the object itself. Now let's understand what are objects and references. In Python, everything is an object. An object is a combination of data and the methods that operate on that data. When we create an object, memory is allocated to store its data and methods. A reference is a way to access an object's memory location. Think of a reference as a pointer that points to memory address where the object is stored. Multiple references can point to the same object, allowing for flexibility in assigning and sharing data. Let's understand what is passing objects in functions. When we pass an object as an argument to a function, we are actually passing the reference to that object. The reference acts as handle that allows the function to access and operate on the object's data. Let's consider an example to illustrate this behavior. In the code above, we define a function modify list that takes a list first as an argument. Within the function, we modify the list by appending two elements 4 and 5. After calling the modify list function with my list as the argument, we observe that the original list has been modified when we print it. This behavior occurs because the function modify list receives a reference to the original list, allowing it to directly modify the object's data. There are two types of objects, immutable and mutable objects. It is essential to understand the difference between immutable and mutable objects when discussing pass by object reference in Python. Immutable objects such as integers, strings, and tuples cannot be modified once they are created. When we pass an immutable object to a function and modify it within the function, a new object is created instead. The original object remains unchanged. On the other hand, mutable objects such as lists, dictionaries can be modified. When we pass a mutable object to a function and modify it within the function, the changes are reflected in the original object. In the example above, when we pass the string myString to the modify string function and concatenate world to it, a new string object is created. However, the original string object remains unchanged. In contrast, when we pass the myString function to the modify list function and append the value 4 to it, the original list is modified. Now let's understand what is copying objects. If we want to pass a copy of an object to a function instead of its reference, we can create a copy explicitly. Python provides several methods to create copies such as copy module, slicing, and the list or dict constructors. Copy Python, copy import, copy def, modify copy list, list.append are some examples. Now the final topic is recursive functions. Recursion is a powerful concept in computer science and programming that allows a function to call itself during its execution. It is particularly useful when solving problems that exhibit a repetitive structure. In this essay, we will explore recursion in the context of Python programming, discussing its definition, demonstrating its implementation through code examples, and highlighting its advantages. Definition of recursion. Recursion is a programming technique in which a function solves a problem by calling itself, either directly or indirectly. It is based on the principle of breaking down a complex problem into smaller, more manageable subproblems, eventually reaching a base case that doesn't require further recursion. To illustrate the concept of recursion in Python, let's consider an example to calculate the factorial of a number. In the code above, we define a function factorial that calculates the factorial of a given number n. The base case occurs when n is equal to 0, where the function returns 1. Otherwise, the function multiplies n with the factorial of n minus 1, which is computed through a recursive call to factorial. The result is then printed to the console. Being a principal concept, recursion have many advantages. Let's discuss a few of them. Readability and simplicity. Recursion allows for elegant and concise code solutions. It enables programmers to express complex algorithms in a simple and intuitive manner by leveraging the problem's inherent recursive structure. Divide and conquer. Recursion helps break down a problem into smaller, more manageable subproblems. This division allows for a more modular approach to problem solving and promotes code reusability. Solve complex problems. Recursion is particularly well suited for solving programs that can be expressed recursively, such as tree transversal, searching, sorting, and backtracking. It simplifies the implementation and enhances the efficiency of these algorithms. Mathematical modeling. Recursion aligns closely with the mathematical concept of induction, making it an effective tool for solving programs that can be defined recursively. This synergy between recursion and mathematical modeling allows programmers to leverage existing mathematical theories and concepts. Recursive thinking. Utilizing recursion improves a programmer's ability to think recursively, fostering a deeper understanding of problem-solving techniques and algorithmic design. The recursive thinking can be beneficial in tackling a wide range of programming challenges. On a final note, concluding, recursion is a powerful and versatile technique in Python programming that enables the solution of complex program through self-referral function calls by breaking down problems into smaller subproblems and leveraging the base case. Recursion provides an elegant and efficient approach to algorithm design. Its advantages include code readability, the ability to solve complex programs, and fostering recursive thinking. By understanding recursion and its applications, programmers can unlock new possibilities of solving a wide range of programming challenges. Thank you for watching the video.